The fastest plane in the world is the Lockheed SR-71 Blackbird, which is also the fastest manned aircraft in the world to this date. Developed by Lockheed Martin, this jet was capable of reaching speeds of over 2,200 miles per hour, Mach 3, making it the fastest jet ever built. SR-71 Blackbird is a reconnaissance aircraft that was operated by the United States Air Force from 1964 to 1998. So in this video, we are going to talk about the rise of the SR-71 Blackbird, a look into its history and legacy. The video is going to be amazing, so make sure you stick to the end. Lockheed's previous reconnaissance aircraft was the relatively slow U-2, designed for the Central Intelligence Agency (CIA). The late 1957, the CIA approached the defense contractor Lockheed to build an undetachable spy plane. The project, named Archangel, was led by Kelly Johnson, head of Lockheed's Skunk Works unit. The work on Project Archangel began in the spring of 1958, with aim of flying higher and faster than the U-2. The CIA approved a $96 million contract for Skunk Works to build a dozen spy planes, named A-12, on 11 February 1960. The 1960 downing of Francis Gray Powers U-2 underscored its vulnerability and the need for faster reconnaissance aircraft such as the A-12. The A-12 first flew at Groom Lake, Area 51, Nevada, on 25 April 1962. The USAF had planned to redesignate the A-12 aircraft as the B-71 as the successor to the B-70 Valkyrie, which had two test Valkyries flying at Edwards AFB, California. The B-71 would have a nuclear capability of 6 bombs. The next designation was RS-71, Reconnaissance Strike, when the strike capability became an option. However, the USAF Chief of Staff Curtis Lee May preferred the SR designation and wanted the RS-71 to be named RS-71. Before the Blackbird was to be announced, Lee May lobbied to modify Johnson's speech to read SR-71 instead of RS-71. The media transcript given to the press at the time still had an earlier RS-71 designation in places, creating the myth that the president had misread the plane's designation. Before we move on, support us by hitting subscribe and the bell icon to get notified when we post new videos. Now, let's get back to our topic. The black paint job, designed to dissipate heat, earned it the nickname Blackbird, and paired with the sleek lines of the long fuselage, made the plane look unlike anything that had come before. A design that hasn't lost any of its brilliance. It still looks like something from the future, even though it was designed back in the 1950s. Peter Merlin, an aviation historian and author of Design and Development of the Blackbird, said in a phone interview, "Because of the way the fuselage bends and the wing curves and twists, it looks more organic than mechanical. Most conventional airplanes look like someone built them. This one almost looks like it was grown." During aerial reconnaissance missions, the SR-71 operated at high speeds and altitudes, Mach 32 and 85,000 feet. 25,900 meters, allowing it to outrace or entirely avoid threats. If a surface-to-air missile launch was detected, the standard evasive action was simply to accelerate and outpace the missile. On average, each SR-71 could fly once per week due to the extended turnaround required after mission recovery. A total of 32 aircrafts were built. 12 were lost in accidents, with none lost to enemy action. In 1989, the USAF retired the SR-71 largely for political reasons. Several were briefly reactivated during the 1990s before their second retirement in 1998. NASA was the final operator of the Blackbird, which used it as a research platform and retired in 1999. Since its retirement, the SR-71's role has been taken up by a combination of reconnaissance satellites and unmanned aerial vehicles, UAVs. A proposed UAV successor, the SR-72, is under development by Lockheed Martin and scheduled to fly in 2025. The heat generated by airflow over the skin of the aircraft would melt traditional aluminum airplanes. A titanium alloy, which provided exceptional strength and heat resistance, was used in 85% of the airframe. Ironically, titanium was in short supply during the Cold War. The US has few titanium resources. The only place on Earth where large amounts are found is within the Soviet Union. To procure enough titanium to build the planes, the CIA worked undercover, forming bogus companies in third world countries to procure it. Another challenge came from working with titanium. The metal is so strong that conventional machinery processes had to be retooled. Even with titanium, the heat caused major expansion during flight, The surface had to have a corrugated texture, which allowed the metal to expand vertically and horizontally. The SR-71 pilots had to wear protective suits while flying because of the tremendous speeds and altitudes they could attain. Their helmets resembled those worn by astronauts traveling to space, and these suits were pressurized to ensure that they would breathe correctly while at a high altitude. Their helmets were fitted with hoses that linked to an oxygen supply. The SR-71 Blackbird featured one of the most cutting-edge cameras on board. Another little-known fact about it, with the help of this amazing camera and the plane's ability to fly at a great altitude, it was possible to snap pictures that were 72 miles wide. The SR-71 Blackbird faced various tire problems, which were a major factor in several of its earliest failures. Because of this, Lockheed was obliged to develop special tires exclusively for the Blackbird behind closed doors. The massive weight of the aircraft and the extreme heat produced upon landing were taken into consideration while designing the revolutionary tire. The air inlets allowed the SR-71 to cruise at over Mach 3.2 while keeping airflow into the engines at the initial subsonic speeds. At the front of each inlet, a pointed, movable cone called a spike inlet cone was locked in its full forward position to the ground and during subsonic flight. So, what was it like to fly the Blackbird? Not surprisingly for an aircraft designed to fly at the edge of space, the pre-flight rituals were similar to those astronauts undergo. Before each mission, the two-man crew was given a medical and then a final briefing on the carefully planned flight. They then sat down to a high-protein breakfast of steak and eggs. This had less to do with morale than it did with making sure that the crew was properly fed for the long flight. The meal was also designed to minimize the need to relieve oneself, a very unpleasant prospect at 85,000 feet and no lavatory. In addition, an emergency ejection at Mach 3.2 would subject crews to temperatures of about 450 degrees Fahrenheit, 230 degrees Celsius, then to sub-zero temperatures that would cause them to simultaneously freeze and suffocate while their blood boiled in the near vacuum above 9/10 of the Earth's atmosphere. This would happen before their parachutes ever had a chance to open, so the high level of protection was literally vital. Once the crew was suited up, they were conveyed to the SR-71 in a van equipped with reclining armchairs. On arrival, the pilot sat in the forward seat and the Reconnaissance System Officer (RSO) sat aft. After getting into the cockpit, they had to sit patiently while assistants made sure everything was hooked up and secured, the ejector seat armed, and the canopy closed and latched. The SR-71 was powered by two Pratt & Whitney J58 company designation JT11D20 axial flow turbojet engines. The J58 was a considerable innovation of the era, capable of producing a static thrust of 32,500 lbf. Originally, the Blackbird J58 engines were started with the assistance of two Buick Wildcat V8 internal combustion engines, externally mounted on a vehicle referred to as the AG330 start cart. The start cart was positioned underneath the J58 and the two Buick engines powered a single vertical drive shaft connecting to the J58 engine and spinning it to above 3,200 revolutions per minute, at which point the turbojet could self-sustain. Once the first J58 engine was started, the cart was repositioned to the other side of the aircraft to start the other J58 engine. Later start carts used the Chevrolet Big Block V8 engines. Eventually, a quieter pneumatic start system was developed for use at main operating bases. The V8 start carts remained at diversion landing sites not equipped with the pneumatic system. Though the SR-71 program was headquartered in the US, its two primary bases were at RAF Mildenhall in England and Kadena AFB in Okinawa, Japan. But wherever it took off from, the takeoff procedure was very similar. The great black plane taxied out, and when the go signal was given, the mighty engine let rip and the SR-71 tore down the runway and into the air. Scarcely had the wheels broken contact with the ground than the undercarriage was retracted and the nose pulled up for a fast climb. So that's it. Please like, share, and comment your thoughts below if you liked the video. Remember to subscribe to see our next video. Stay safe, and we'll be back soon with another video.